Hello STEM world, welcome to STEM with Caracas. Today we are gonna doing an experiment to find out the wavelengths and speed of a wave on a vibrating string. Let's talk about what materials that we are gonna need. We are gonna need a sine wave generator that we have here, a string vibrator, some string, a meter stick, a mass pulley system. The reason is because we want to have a constant force acting on the wave, since it has an effect on the wave formation. So the first data that we are going to be recording is going to be the distance between fixed points, between fixed ends, which is from here to that point, okay? And now I want to see the first harmonic on the string. So to be able to do this one, I need to create the waves that is going to occur on the string. To do that, I'm going to give some amplitude. In other words, I'm going to give some energy, the wave energy. Alright. Then I'm going to make the course adjustment by that knob. Let me see if it starts oscillating. Alright. And you see that is my first harmonics that I can observe. Then what I'm gonna do, I'm gonna use that second knob to make the fine adjustments. Alright, that's a pretty good shape for me, so that I can use this one and then I can record the first harmonics frequency. Now if I want, I recorded that number, then if I want to increase the frequency to get the second one, I'm gonna again use the course adjustment knob. So now I can see two loops or second harmonic, as you can see here. Alright, pretty much good. A little bit adjustments that we are gonna need here. So that's pretty cool. That's our second harmonics that we are able to see. And I recorded the number on my data table. Alright. And I can find out the third one too. Let's do it. Do it again. For adjustment. As you see here, if I give that amplitude a lot, since it's hitting the sides of the string vibrator, it's not convenient for me to use. That's why I want to use a less amplitude, less energy, but pretty much accurate wave. Alright, I'm gonna make some more adjustments to make sure that my fixed end is exactly at the point that it's touching, the string is attached to the end. Okay, I'm recording that number too. And one more time, I want to see what's going on here. One more time, the fourth one. So we have fourth harmonic in here. That I'm making my fine adjustment with the knob too. Alright. And a little bit accurate. So let's get yeah, there we go. We have it right now, so it's pretty much good. This is our fourth harmonics. Okay, right now we have this data that we included on the length of the string and the frequencies here. And we know that we can find out the speed of the wave by using that formula. Velocity is equal to frequency times lambda. Lambda is wavelength, f is frequency, and then v for the velocity, the wave speed. So for each individual frequency we are going to be finding out the velocities, and then to see the relationship among them. Right. How do you find out the wavelengths, the lambda of a wave? So the clue was, as you remember, the number of the loops. Alright, in this example, for the first harmony, for the first shape, I had just only one loop, and as we all remember, that's the half of the first cycles. So it's gonna be half of the wavelengths, and then for this we are gonna end up lambda 1 is equal to 2L. And for the second one we have 2 loops, so it's gonna be equal to lambda 2 is equal to L. For the third one this, and then for the fourth one L over 2. Alright, in this example I already did my algebra for you, and then I already calculated by using the lengths that I got from the string, and then I calculate that the lambda 1, the first wavelength, is going to be 3.44 meter. And now I'm completing my calculations, all of them, and then for the first frequency and for the first wavelengths, and found the wavespeed as 36.12, and